Today we are going to talk about how to solve a system of equations using substitution when one equation is solved for a variable. So you'll remember from the last lesson that if we have y equals for both equations, we set them equal to each other. For today, we're going to use a similar concept, but this time we're going to have to simplify a little bit more to solve it. So we're going to go ahead and solve problem A. We have y equals 8x minus 10 and negative x plus 6y equals negative 13. We're going to go ahead and use substitution for this. So if I know that y is equal to the 8x minus 10, I can replace the y in the second equation with that whole expression in the parentheses, the 8x minus 10. So we're going to go ahead and do that. We have negative x plus 6 times 8x minus 10 equals negative 13. And notice I put it in parentheses when I plugged it in. And that's because I need to remember to distribute the 6 through the whole thing. So we're going to go ahead and multiply here. 6 times 8x and 6 times negative 10. So we get negative x plus 48x minus 60 equals negative 13. From here, we just have an equation to solve. So we're going to go ahead and combine like terms. So negative 1x and 48x, that's a 1 there, gives me 47x. And we're going to bring everything else down. We're going to add 60 to both sides. So those cancel. And we get 47x equals 47. So divide by 47 on both sides. We get x equals 1. Remember that when we solve a system of equations, we are actually trying to find the point where the lines intersect. So if I have an x value, I still need to go back and find a y value. So what I'm going to do is I'm going to go ahead and plug this 1 that I just found right here for the x in the first equation. So I'm going to do y equals 8 times 1 minus 10. Well, 8 times 1 is 8. 8 minus 10 gives us negative 2. So my solution is the point 1, negative 2. Now we can check this like we did in the last lesson by plugging the point into the second equation. It should work for the first equation. We'll plug it into the second just to make sure. So I have negative 1 plus 6 times negative 2 equals negative 13. So negative 1, and when I multiply, I get negative 12. So negative 1 plus negative 12 is negative 13. If I get a true statement, I'm good. That's my answer. One other way you could check this is to actually graph those and see where they cross on the graph. If you really want to check them quickly, can't do this on your test, but you can plug both of those equations into Desmos and just find the point where they cross. Let's go ahead and do the second problem here. We are going to do the same thing and plug this negative 7x minus 8 in for the second y. Be really careful when you do this to always remember to put the expression in parentheses. So I have my quantity negative 7x minus 8. And then also be careful when you distribute to pay attention to the signs. So notice that I have a minus 7 there in front of my parentheses. I need to make sure I multiply by negative 7. So negative 7 times negative 7x is a positive 49x, and negative 7 times negative 8 is a positive 56. I'm going to go ahead and combine my like terms. Negative 3 plus 49 is 46. Bring everything else down. We're going to subtract 56 from both sides. So that cancels. So 46x equals negative 46. Watch your signs there. And if I divide by 46 on both sides, negative 46 divided by 46 is negative 1. One of the most common mistakes that I see when students are solving systems of equations is when they're going through and finding the answer for the first variable, they miss a negative sign somewhere. So, for example, students for this problem will get positive 1. Make sure you pay really close attention to those signs, because if you do forget one of those signs, it's going to mess up the whole second part of your answer. So we need to make sure we go through and check carefully. Distributed in negative, so negative times a negative is a positive. Same thing for my 56. When I combine like terms, I got a positive here. When I subtract, I have my negative. So when I divide, a negative divided by a positive is a negative. When I'm grading your test, if you miss a sign but use your incorrect answer correctly in the second part, you won't lose all those points. You'll just lose part of your points. So what I'm doing now is I'm just going to go ahead and take the negative 1 that I found and plug it in for my x in the first equation. So I'm going to do negative 7 times negative 1, which is 7, and then minus 8. So 7 minus 8 is negative 1. So I have a point, negative 1, negative 1. And again, a couple ways you can check this. You can graph this on graph paper. You can go ahead and plug those two equations into Desmos, or you can just plug these two answers into the second equation and make sure they work. So if I do negative 3 times negative 1 minus 7 times negative 1, that should equal 10. So negative 3 times negative 1 is positive 3. 7 times negative 1 is positive 7. And 3 plus 7 is 10. So we're in good shape. Okay, we're going to talk a little bit about special cases. Let's look at these closely and kind of see where we're at. Tell me if the following are true or false. Okay, is 6 equal to 6? Yeah, that's true. Is 0 equal to 5? Not so much, so that's going to be my false. Negative 3 equal to 2? Again, false. And 0 equal to 0? That one's true. The reason we're paying attention to this is because if I get something like 6 equals 6 or 0 equals 0, and those are true, I have a special case where it's infinitely many solutions. If I get something like these middle two that ends up in a false solution or a false statement, I have no solution. Okay, so let's go ahead and do these next two. Notice in this next problem here, the y is by itself on the second equation. Okay, so we're just looking for where the y is by itself, and we're going to take that expression and plug it in for the y in the other equation. So when I do that, I have 6x minus 2y equals 4. Check that. We're going to erase that. Forgot to plug this in. Okay. Sorry. We're going to go ahead and take my 3x minus 2 and plug it in for the y in the first equation. So we're going to do 6x minus 2, and then in my parentheses I have 3x minus 2 equals 4. I'm going to solve this the same way we have been. So we're going to distribute the negative 2. So 6x, and then negative 2 times 3x is negative 6x, and negative 2 times negative 2 is positive 4. We're going to go ahead and combine my like terms, but when you look at the like terms here, notice that I have a 6 and a negative 6, and those actually cancel each other out. So I get to this point. If my variables cancel completely, okay, there aren't any x's or y's left, I need to check to see if my statement is true or false. Okay, if 4 is equal to 4, that means I have infinitely many solutions. Okay, infinite solutions. That means when I graph those two, I end up with one line on top of the other. If I were to solve this and get something that's not true, then it would be no solution. Let's look at the second one on this page. So y is by itself in the first equation. Okay, and it's equal to negative 3x minus 2. So we're going to plug that in for y in the second equation. So we're going to do 9x plus 3 times the quantity negative 3x minus 2, and that's equal to negative 2. Okay, so we plug the negative 3x minus 2 into the parentheses, or in for the y in parentheses. We're going to distribute So I have 9x, and then 3 times negative 3 gives me negative 9x, and 3 times negative 2 is negative 6. So notice in this problem that when I go ahead to combine my like terms, 9x and negative 9x, they cancel out, but I get negative 6 equals negative 2. It's not possible. Negative 6 will never be equal to negative 2. So we're going to go ahead and say this is no solution. Okay, so you have 2 special cases there that will pop up. You need to be aware of both of them because they will be mixed in with other problems. Okay, so again, if your variables cancel, you either have no solution or infinitely many solutions. Okay, so if the variables cancel, you have either no solution or infinitely many solutions. Go ahead and try these guided practice problems. And when you finish, have your answers checked. And if you have them done correctly, we will give you your homework. If you made a mistake, we'll help you figure out that mistake. Just kind of as a summary here, today we did solving systems using substitution. This is the second day doing that. You have another worksheet for 5.3. Tomorrow you are going to have a 5.1 through 5.3 quiz, and then we're going to start using elimination. And actually, I think we're just going to focus on 5.3 on the quiz tomorrow instead of the graphing as well. Make sure you have your Chromebooks with you and charged because you will be taking the quiz on Canvas. If you have any questions, let us know. We'll help you out.